So 2 episodes ago, I introduced you guys to the Python interpreter and how to write single line and multi-line comments. And in the last episode, I covered the 4 main operators within Python, as well as how to write mathematical expressions. So yeah, I'm going to open up the terminal now, and I'm just going to kind of show you a sort of recap of everything I've done, and then from there we'll take it forward. So to access the Python interpreter, you can open the terminal. I'm using Linux, but if you guys are using Windows, then command prompt is what you want, and in Mac OS, the terminal, again similar to Linux, is what you want. And to invoke the Python interpreter, you just type Python and it will open up the interpreter, such as what you can see on the screen now. So yeah, what I'm going to do is I'm going to write a comment, and I'm going to type Python operators review. So 1 plus 1, that's addition. 2 minus 1, that's subtraction. 2 multiplied by 3, that's multiplication. And 4 divided by 2 is 2. Notice how in the division, even though 4 divided by 2 is a whole number, it still does 2.0 and not 2. And the reason why that's the case, I explained it in the previous video, but just as a recap, division is the only operator where the output may not be an integer. It might be a decimal point. If you're doing 5 divided by 2, it's 2.5, not 2. And so in order to save on kind of memory, etc., these operators will always return an integer, but this one, Python, will always default to a decimal point irrespective of what the output might be. Now, what if I did want an integer output, not a decimal, I just wanted an integer output? Well, this can be done. More Python operators. And let's zoom in a little bit. This can be done using the double /, and what this will do is it will give you an integer output. If I do the same thing with just 1, it will give me a decimal point of 2.0, but with the double, it will give me an integer value of 2. This operator is called the floor division. So what it does is you divide 2 numbers, and whatever output comes out of it, round it down to the nearest whole number, not up. This is where Python can deviate from standard arithmetic. If a number is 2.5 is greater than or equal to 2.5, it will round it up to 3. But in Python, if it's 2.7, it's going to round it down to 2. Always. It's a floor division as opposed to a ceiling division. So, you know, what does that look like if I actually output a decimal number? So if I do 5 divided by 2, right, that gives you 2.5. But if I do 5 double /2, that's going to give me 2, because you're basically telling it, okay, 5 divided by 2 is 2.5, right? Round it down to 2 and make it an integer. And that is what the floor division operator does. So that's that. The next one is the modulus operator. So the modulus operator is basically, it basically fetches the remainder of a division. So if we use this same example of 5 divided by 2, that's 2.5, right? And if we do 5 floor of 2, that gives you 2. Now, how many 2's do you need to reach 5? If we do 2 plus 2, that equals 4. But 2 plus 2 plus 2 is equal to 6. And that exceeds 5. We're out of scope here. So 2 plus 2, right? 2 plus 2, that equals to 4. And to get to 5, we simply have to add 1, right? 2 plus 2, add 1 is equal to 5. And this is equal to 5 modulus 2, and that will give you 1. Because what you're basically saying is squeeze in as many 2's as you can into 5, and then whatever remaining number you have to add to reach 5, that is what it outputs. So where would this be useful in Python? Why would you want that in Python? Well, let's say you only want to fetch even numbers from a sequence of values, and you wanted to filter only on even numbers. Well, the Pythonic way to do that would be to apply this modulus operator. You would say, okay, I've got 7 modulus 2, that's 1. We've got 95 modulus 2, that's 1. But 96 modulus 2 is 0. And when the modulus of an expression is 0, then that means that you know that the number is even. Looking at the numbers, you know that they're even because it ends in an even number. But if you don't know what the number is, and I'll get to that later in this video, then the modulus operator can be a really useful indication of telling you whether a number is even or not. If it outputs 1, then it's another number. If it outputs 0, then it's an even number. And this only works if you do modulus 2. If you do modulus 3 or 4, it will do the same thing, but instead of 2, we'll do it for 3 or for 4 or whatever. So yeah, that's that. The next additional operator I want to show you is the exponential operator. And this is basically like if you do 4 to the power of 2 will give you 16, right? This is basically what you're saying is 4 multiplied by 4, but you're multiplying 4 twice, and therefore that gives you 16. So this first expression is equal to this expression. And as an FYI, exponents are prioritized in a mathematical operation over multiplication, division, etc. So if I do, 4 plus 3 times 2 exponent of 2, right? This could give you a range of results. It could be, 3 times 2 is 6, times 6 is 36, plus 4 is 40, or it could be 3 plus 4 is 12, multiplied by 2 is 24, and then 24 to the power of 2, but the real answer is actually going to be 16. Oh, actually, yeah, let me do this. So the real answer will be 28, because it's going to prioritize this first, 2 to the power of 3, because this operator is prioritized first. So that will be 8, and then 8 multiplied by 3, 24 plus 4 is 28. So if to continue with the review, if you wanted to prioritize 4 plus 3 multiplied by 2 to the power of 3, then it will prioritize this first. So that's just one point I wanted to make about the exponent. The exponent is basically x to the power of y, such that x is the number that you're dealing with, and then y is however many times you want to multiply x by itself. So that is the exponential operator. I'm kind of explaining maths as well as Python, but I guess, yeah, it's a good way to sort of brush up on your math skills, or like basic arithmetic skills. So that is that operator. The last operator I want to show you in this video is the equals operator. Why did I bring this up? Because so far all I've shown you so far from an operator standpoint are like computations. So like you're either adding numbers together, multiplying, subtracting, dividing numbers, or you're doing some sort of more complex arithmetic, such as getting the remainder, or ensuring that the output is a floor, is a integer, or doing exponents and whatnot. But equals, like, what does that mean when you do one number equals another, or something equals something else? How does that work? Well, it's not really a mathematical operation in Python. It's not. The equals operator is an assignment operator, right? When you use the equals, because think about it this way. Let's say I have an application that tracks my calories for the day. And, I eat an omelette in the morning. I log my calories in. I eat like an apple or banana and some sweets for as a snack. I'll add those calories up and then store it. At the end of the day, I will want to look at everything I've eaten today, tally it all up, and add them all up together to get my total calorie count for the day, right? If the only thing that Python or general programming languages could do is do stuff like this very well, but does not store this 8 anywhere, then it's kind of useless. It's only really good for like in the moment calculations. But what if you needed something that actually sits somewhere and comes back to you later on? Well, the equals operator is the way you can assign the output of any expression you provide to a location in memory and therefore storing it. So let's say we have x, right? And x is equal to 2, right? This operator basically instructs Python to take this value of 2 and assign it to x. And when I press enter, nothing happens, right? If you see, like so far, every single thing we've done, right, returns some sort of value. But when I do x is equal to 2, that does not return a value. And the reason why is because what's happening here is you're not giving Python a computation here. You're not. You are telling Python to store something, right? So it's not returning anything. If I wanted to then call this variable, then what I would need to do is press X, enter, and it will give me 2. Now, to really drive this home and make this make sense to you, let's say that instead of x is equal to 2, we do x is equal to some operator. Let's say x is equal to 5 times 6, right? 5 times 6 is 30. When we press enter, nothing happens. But then if I call x, it's going to give me 30. And that is what the equals operator does. It takes whatever you want at some value, right? Or the output of a mathematical expression, save that in, similar to how you save an Excel file or a Word file, you're saving the output of whatever it is you've done to a variable. Equals operator takes care of that. And you can do more than one variable, right? Let's say, let's update this to variables. Let's say, we have x is equal to 7 times 4 plus 46, right? And we store that. And then let's say y is equal to 9 times 4 minus 46 divided by 8, right? And then we store x and y. That's one. This expression gets stored in x, and this expression gets stored in y. And then if I want to print x, we get 74. If I want to print y, we get 30.25. And then if I want to do x, see, I've just introduced a new concept, right? Storing variables using an equals operator, and now we have x and y as distinct numbers. Because x is the identifier of the value of this expression, it basically stores this value. It's like, this is equal to this now. You've told Python that this is equal to this, right? Why am I drilling this down in terms of explaining it? Because what I'm trying to get at is, if I then do x, right, plus y, if this is equal to this and this is equal to this, then this plus this is equal to this plus this. And so if I press enter, 74 plus 30.25 is 104.25, right? And this is where kind of not only can you do computations and stuff, but you can also do a little bit of algebra here as well. So you can do 2 times x, right, plus y. And this will give you a valid response. So not only can you do basic computations, but by being able to store the output of mathematical expressions in a variable, then you can actually perform equations, which is another form of an expression. This is an expression, and then you can store this in an equation. So let's say line of best fit, right? And I decided to use like a sentence here instead of just a letter to also tell you that variable names can be whatever you want it to be, right? So I've just done that, and then if I do this, then that gives me the same result. So yeah, I would go into more about naming variables, but I'm actually going to do that in the, should I do it in the next episode, or I'll do it in some episode in the future? Yeah. Oh, anyways, all right. Like and subscribe, and yeah.